All right, so we've got the velocity of a thrown baseball, and we've been given an equation. Now, I want to back up, and let's talk about what we know, okay? What we know is if you're given position, S of t, that the derivative of S of t is equal to velocity. And we know that the derivative of velocity is acceleration. Okay? Another way to write that is S prime equals V, and V prime or S double prime equals A. Okay? So we know that. Now, we also know how to work backwards now. Okay? So knowing that information from our derivative chapters, here's what we know. They've given us the velocity equation. They've asked us to find displacement. The antiderivative of velocity is going to be displacement, right? His derivative is velocity. His antiderivative is displacement, okay? So they've given us V of t. They've asked us to find S of t. So we're going to take the antiderivative of negative 32t plus 75 dt, okay, with respect to t. All right, so we'll take this guy, we're going to add to him. So that's going to be t squared, okay? Now, when I take that derivative, I get 2t. I need 32t, specifically negative 32t. So that's going to be negative 16t squared, right? Because 2 times negative 16 is going to give me that negative 32. And then the antiderivative of 75 will just be 75t, right? And when I take his derivative, 75t is just 75, and then plus c, okay? We're not done, though, because they told us the initial displacement is 30 feet. Now, what that means, I'm going to take what that means and write it here in green. When time is 0, the displacement is 30, okay? So if that and that are 0, this expression has to be equal to 30. If that and that are 0. So that very obviously makes C 30. So S of t, our displacement equation, is negative 16t squared plus 75t plus 30. Okay? So that's how we find displacement given velocity. Very, very similar to the derivative applications we did earlier in the semester. Okay, find S and V after 2 seconds. So we're finding S of 2 and we're finding V of 2. Okay, well, S of 2 is going to be negative 16 times 2 squared plus 75 times 2 plus 30. Okay. We'll do a little figuring here. Okay, well, it's going to be 16 times 4, and it's going to be negative. So that's negative 64. And then 75 times 2 is 150. Okay, so negative 64 plus 150 plus 30. I get 116. And they gave displacement in feet and time in seconds. So this will be 116 feet because it's displacement. Okay? And then velocity at 2, right, will be our original function, negative 32t plus 75. And that t will be replaced by 2. Okay? So negative 32 times 2 is negative 64. And then plus 75 is going to be 11. And the units, because this is velocity, will be feet per second. Okay, so we found S of 2 and V of 2. Now, the last piece, find the maximum displacement and the time that this occurs. So displacement S of t is equal to negative 16t squared plus 75t plus 30. How do we find maximums or minimums? Well, a maximum is where the derivative is equal to 0. Okay, it's where the derivative is equal to 0. And we have the first derivative and the second derivative test that we can use. So, I already know the derivative, s prime of t, was given in the problem, right? This is the same as velocity. Oh, well, that's just negative 32t plus 75. Set that equal to 0. Okay, so you move the 75 over and you divide by 32 and you get, depending on how you work this, you get 75 over 32, or you get a fun decimal, 2.34375. Okay, so it depends on if you want an exact or an approximate answer. Okay, cool. So depending on what you want, now since this is time, we're going to say it's in seconds. Okay, and I'll go ahead and box the exact answer, but if you want the approximate answer, you can round. Now, they ask for two things. They ask for the maximum displacement and the time that this occurs. Now, I'm skipping a step. I've kind of done this in my head. S of t has a negative leading coefficient. So I know that this graph is shaped like that. So I'm skipping where I prove that this is a maximum because I know this is a downward facing parabola, and that one magic point that we're going to find where the derivative is equal to 0 is in fact the maximum. So I've skipped proving that because I know it to be true already. Okay? And then, so we found the time. They want to actually know the maximum height. So what do? We find S of 75 over 32. So negative 16, 75 over 32 squared plus 75 times 75 over 32 plus 30. Find the maximum displacement. So that's going to be a lot of fun. So we take 75 over 32 and we square that, and then we multiply by negative 16, and I get a fun number. And then I'm going to add 75 times 75 over 32, and then I'm going to add 30. And I get 117.89 feet if we go with a decimal. If we go with a fractional answer, it's going to be a real messy number. So we'll go with the decimal answer. Although it wouldn't surprise me if some of your teachers required an exact value, but that would be pretty messy. Okay, so we know our maximum height. There's our maximum height. And there's the time, whichever one of those you want, to get to that maximum height. Okay? So anyway, fun application with antiderivatives. If you have any questions, leave them in the comments.